Consider the following graph of a triangle on the plane. How long is this slanted blue line? Well, if you look at this shape here, we have a right triangle. So we're going to use the Pythagorean theorem. All right, so all we need to know is the distances of the two legs, and then we can find the distance of this blue line, which is the hypotenuse. And the distance of these two legs, well, the distance is going to be 1, 2, 3 up. And the distance across is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. We can do that because these are straight line distances. All right, so the blue line, which we'll label as C equals the square root of 3 squared plus 9 squared. That'll give us 9 plus 81. The square root of 90. And simplifying the statement down, 90 is the same thing as 9 times 10. So I can write it as the square root of 9 times the square root of 10, which of course is 3 root 10. This is the exact answer. You can, of course, plug that into a calculator and get an approximate decimal solution. Now, this process for this triangle, of course, is not unique. You can use Pythagorean theorem on any right triangle. So let's consider a different set of points. And we're asking how far apart are these 2 points? Well, to do that, we just can draw a straight line. I'll draw it in blue here. We're asking what's that distance if it were straight, whatever. All we have to do to find this distance is create a triangle out of it, right? So I'm going to go straight across and then go straight down. And then we have a similar triangle that we just solved. We ask what are the distances of the legs. So this one's going to be 1, 2, 3, 4, 5, 6, 7 units across, and 1, 2 units down. So to find this distance, we'll call C again. This is just a right triangle. We can do C equals 7 squared plus 2 squared. It's going to be 49 plus 4. And that's going to give us the square root of 53. And I don't believe that can simplify down at all. So that is our exact solution. Now, to get the side lengths, instead of doing this counting thing that we're doing, we can subtract to get these side lengths. Subtraction is always the idea of distance, but you have to make sure you use the absolute value because these side lengths, any kind of a distance is always a positive or 0 number. It's never negative. And subtraction can give you a negative. So you must do the absolute value of the subtraction to get the right distance. And subtraction also works nicely when you have problems like this, where the points aren't on these exact grids. Of course, this one is on the exact grid for this system, but this one is not. So subtraction may actually be a better way of doing that. However, the process is still the same. Draw a straight line. To find that distance, all we have to do is find this distance and this distance here. Okay, so for this height, all we have to do is take the higher minus the lower, or either of the y values. It doesn't matter which one. So this one's -2, so we're going to do -2 minus this y value, which is 0, and take the absolute value of that. That's going to give us -2. The absolute value of -2 is 2. So this distance here is 2. This distance across is going to be the absolute value of, it's going to be the x values, right? -3/2 minus 2/3. Okay, doing that, we have to get common denominators, of course. That's going to give us the absolute value of -9/6 minus 4/6 which is the absolute value of negative 13/6, which of course is just 13/6. That's this distance across. Okay, then to find c, all we have to do is do the Pythagorean theorem. So 13/6 squared plus 2 squared and the square root of that. Okay, it's going to give us 169 over 36 plus, this is the same thing as 4 over 1. So we'll get common denominators. So give us 169 plus, I believe, 144 over 36. Okay. Let's see, 169 plus 144 is 313 over 36. And here we can distribute the radical on top and bottom, because the 36 reduces down to just 6. The square root of 313, well, 313 is prime, so the square root of 313 cannot be reduced at all. And so that is our final answer. That's the exact answer. Once again, you can just use a calculator to get an approximation. So this process I've been doing here using the Pythagorean theorem to calculate a distance is pretty basic, but there's a general formula called the distance formula. As you can see here, this is just Pythagorean theorem. So replace d for distance with lowercase c. You can square both sides. This is the horizontal component, x2 minus x1. That's just this component up here. And the subtraction just allows for finding the actual distance. So this is just one leg of the triangle. So you could say that that's just a, for instance. And this distance here is the distance of the y direction. That's just another leg of the triangle, so b. So the distance formula is just Pythagorean theorem, but in a little bit more nicer form for the Cartesian coordinate system. So knowing the points x1, y1, and x2, y2, that's actually what I was doing here. I was doing x1, y1. Sorry, x1 minus x2, then y1 minus y2, or the other way around. The absolute value allows you to do it either way. The same thing is true for the square. The square allows you to do it either way. But that's all the distance formula is. It's just Pythagorean theorem. So if distance formula doesn't make much sense, just draw a triangle on the plane and solve that triangle. Give it a try in number 1. Now, as I said, squaring both sides of this thing, this will give us d squared equals x squared minus x1, sorry, x2 minus x1 squared plus y2 minus y1 squared. And then I can change some of these variables. So I'm going to change x2 to x. So this is just going to go to x. y2 to y. I'm going to change this one to h, this one to k, and change the d to r. That's going to give me, I'm also going to flip this around. So it looks like this. X minus h squared plus y minus k squared equals r squared. And this is a circle. It's the equation that graphs all points a certain distance or radius away from the center point hk. That's all this is saying here. There are, of course, two pieces of information, like I said, the radius r and the center hk. Okay, let's actually look at these things in practice. So we're going to graph this circle below. Of course, just use graphing software, but this is really easy to graph. The center is at, remember, it was x minus h, y minus k. So h here is 4. K is -1. Yeah, it has to be y minus -1, so y plus 1. So our center is at 4, -1. And the radius, it's r squared. Go back to the formula, and you see we have r squared here. So the radius is not 16, but the square root of 16, which is 4. So all I need to do is plot the center point, which is at 4, -1. So 4, -1's right here. And then from this point, go a radius of 4 units out and draw the circle that results from it. So from this point, go 4 units out. I'm going to go in the cardinal direction. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then 1, 2, 3, 4. And then I'm going to connect these points with a smooth circle. It's going to look like this somewhat, and then down here, over this way, and up. And so all the points on this circle are 4 units directly away from the center. So this point here is 4 units. This point down here is 4 units, and so on and so forth. So that is the plotted circle. Now, if you're looking at a circle graph, to find the equation of this circle, all we have to do is find the center and the radius. The center is going to be halfway between each of the 4 sides. So this one's going to be 1, 2, 3, 4, 5, 6 units across. So the center is going to be 1, 2, 3 units in. It looks to be this point here. 1, 2, 3, 1, 2, 3. Yeah, that's the center point. So the center is at, it's going to be -1, 0. And the radius is how far away the circle is from this central point. And I already counted it. It's 3 units away. These are all 3. So the radius equals 3. That means I can write the equation of this circle really easily. It's going to be x minus h. H is the x coordinate. So x minus h is going to be x plus 1 squared plus y minus k. K is 0. So y minus k is going to be y minus 0, or just y squared, equals the radius squared. The radius squared is 3, so the radius is 3, radius squared is 9. That's the equation of this circle. Give it a try in number 2 and 3.